All right, in this video, we're going to be talking about using technology. So in the previous videos, we've been talking about how to make a histogram or excuse me, a histogram or a box and whisker plot or a dot plot. And in this video, we're going to be talking about how to do those with technology. So we're going to be going back to the potato chip problem, the Lay's potato chip problem. So originally, the manufacturer said that each bag has 28.3 grams of potato chips. And so what we did was we collected data on bags of potato chips. And it says, suppose data were collected on 25 bags of Lay's potato chips. The weight to the nearest gram of the potato chips in each bag is listed below. Create a dot plot of the potato chips data and describe the distribution. So we've got a dot plot, we got a number line here, and we need to make a dot plot with the data that's given to us. And so anytime I have a 25, I'm going to put a dot on 25, dot on 28, or I have a data point for 28, so I'm going to put a dot. So I'm just going to go through and make a dot for each of these. So we got 23, 26, 23, 25, two 25s, two 24s, 27, then 23, 24, 28, 27, 24, 26, 24, 25, 27, 26, 25, 26, 24, and then two more 25s. Okay, and it says, does the distribution appear to support or contradict the manufacturer's claim of an average weight of 28.3 grams per bag of chips? And explain your reasoning. Well, the average weight looks to be well below that. So we didn't even have a single bag at 28.3 grams or above. So I'm going to say the average weight looks to be well below the manufacturer's claim. And I'm going to say every bag in the sample was below the advertised weight. So it says, use your calculator or spreadsheet software to create a more formal display of these data. Make a sketch of the results here and save an electronic copy of your formal report. If you create a histogram, remember to carefully consider your bin size. So if we're making a histogram, okay, so what I've got is my graphing calculator. So I'm going to drag this over here. And what I want to do in order to make a histogram on a graphing calculator, I need to look at my list of data. So here, let me clear this real quick. So I've got my list of data right here, and I'm going to be putting this data in my calculator first and then creating a box plot from it. So in order to put it in your calculator, you got to hit Stat, go to Edit, and then I've already listed mine in here for convenience. All of my data right here is in list 1 right here, okay? Now, to make a histogram of it, okay, we need to hit second Y equals. And it's going to bring me to the stat plot page. First thing you want to do, make sure stat plot 2 and 3 and 4 are all turned off. See how they say off? And then we're going to be using stat plot 1. So highlight stat plot 1 and hit enter. And then from here, you can turn it on, and then you can choose what type of graph you want. So we're doing a histogram. So the bar one is the one you want to highlight. Just highlight it, hit enter. X list is going to be asking, where is your data? Mine is in list 1, so keep it at that. Frequency, just leave it as 1. And then if you have a TI-84, you can choose the color. You can choose whatever you want. It really doesn't matter. And then to be able to view your graph, see this at the very top center of your calculator, you see the zoom button. If you hit that and then press the number 9, it'll create your graph for you. Now, it's not going to list out numbers or anything like that, but just off of this graph, you should be able to see, okay, what's the distribution look like? Is it symmetrical? Do we have any possible outliers? Things like that. From part 1, we still have one more thing we have to do. Question 1, it says, let me clear this. It says, describe the distribution. So in part 1, our range is somewhere between 23 and 28. So I'm going to say range is from 23 to 28. Now the shape of it's fairly symmetric, so we can say it's roughly symmetric. And it's centered around 25. Okay, see how most of our data is lying on the 25 right here. And then the only other thing, it doesn't look like there are any outliers, so I'm going to say no outliers. We don't have any dots that are way down here or way up here. And now that graph that we created, okay, so we've got a graph that we created on our graphing calculator. And then if you go over to page 3 in your notes, you'll see one that's already been created. So just to compare and contrast what you have. Number 4 says you can also use your calculator or spreadsheet software to create more precise numerical descriptions of the data. This approach is quicker and usually more accurate than computing by hand. So if I were to bring out my calculator again, okay, in order to find this data, we did this in the last video, but I already have all my data in list 1. So from here, I can hit stat, go over to calc, and then do one variable stats. And it's going to ask me what list. My data is in list 1. I hit calculate, and it gives me all the data. So the mean of the data is X bar, that very first number. In this case, it's 25.16. So I'm going to say 25.16. The standard deviation, it's represented as an SX, so it's the fourth one down. In this case, it's 1.46. So I'm going to say it's 1.46. The number of data values is n equals. So if we look at n equals on our calculator, that tells me how many pieces of data I was given. So I measured 25 bags of chips. So in this case, n is equal to 25. And then the 5-number summary. So we have our min. If I scroll down a little bit, I've got min is 23. Q1 is 24. Median is 25. Q3 is equal to 26. And max is equal to 28. And now it says, let me get rid of this real quick. It says, sometimes it makes sense to analyze the proportion of a population that meets some criterion. This is another method for investigating whether the manufacturer is correct in claiming that the average weight of a bag of chips is 28.3 grams. Write a statement or hypotheses involving the proportion of bags of chips that meet a weight criterion. So if we're looking at the weight should be 28.3 grams, it's never going to be, even at a manufacturer's level of sophistication, they're not going to get perfectly 28.3 grams every time. We shouldn't expect that. What we should expect is that the average should be 28.3 grams. So if we're looking at an average, that means 50% of the data should be below 28.3 and 50% should be above 28.3. So we can say we expect 50% of all bags of chips weigh 28.3 grams or more. Because a manufacturer is not going to be perfect, so we should see about half of them be above that value and half be below. And now it says, what proportion of the bags in your sample were 28.3 grams or more? Does the answer change your opinion about question 2, and why or why not? Well, none of our bags of chips were 28.3 grams. So we can just say 100% of the bags in the sample weighed less than 28.3 grams. And question 2 was, does the distribution appear to support the or contradict manufacturer's claim? So we can say yes. We didn't even have one bag. With 28.3 grams. Now, number 7, it says, suppose instead that the weight of the chips in each Lay's bag is the following. Produce a histogram and recompute the descriptive statistics for this set of data. And what do you notice? So they've given us a new set of data to work with. Instead of that original data, we have these weights to go by. And so if we're creating a histogram, the first thing I want to do is I want to try and find my smallest value and my largest value. This will help me figure out what my number line needs to be. So my smallest value looks to be about 22, and my largest value looks to be about 30. Looks to be about 34 right here. Yeah, it looks about 34 is our biggest value. So 34 to 22. So I'm just going to start at 20 and go up by 2s. So I've got 20, 22, 24, 26, 28, 30, 32, 34, 36. I'm actually going to redraw that so it takes up the entire space. Okay, so I've got 20, 22, 24, 26, 28, 30, 32, 34, 36. And you know what? I'm going to mark it with the 1s as well. I'm not going to number them, but I'm just going to mark them with 1s as well. So I've numbered it by 2s, but I've got tick marks for every individual one. And so anytime I see a value, I'm just going to put a box right there on my histogram. So I've got 29, that goes right here. 34, that goes right here. Um, 22. Before I continue any further, what I want to do actually is I'm going to mark off my y-axis. So I've got 1, 2, 3, 4, 5. Okay, and so I've got these 3 done. I need 27 and 26. So I've got 27, 26. 25, 28, 24. 26, 33, 28. 29, 31, 30. 27, 28, 31. 28, 32, 25. 31, 28, 30. And 29 and 27. Okay, so I've got my histogram right here, and it says the standard deviation for the data, the number of data values, and the 5-number summary. So I'm going to have to put in all these data points into my calculator. And for convenience, I already have them on here. So if I go to Stat, Edit, I've put all my data in list 2 this time. You might put yours in list 1. Either way is fine. But you go Stat, go over to Calc, and then do one variable stats. In this case, I have list 2, so I'm going to hit second 2, and see how list changed to list 2. And I go down to Calculate, and now I've got all my data. So I've got SX, which is our standard deviation. In this case, is 2.84. Number of data points in is equal to 25. My 5-point summary, so I've got min is equal to 22. Q1 is 26.5. Median is 28. Q3 is 30.5. And max is 34. And then one other thing that is missing is our mean. So our mean is equal to 28.32. All right, so I'm done with my calculator. I'm going to throw that to the side. And now I've got all my data points right here. So that's how you would create one by hand if you were doing a histogram.